Hello, my name is Lauren Wood, class of 2006, and I serve the college as coordinator for alumni and family relations. On behalf of the college, I welcome each of you to the series NOKELive presented by the Roanoke College Alumni Association. This event is being recorded and will be available on this Roanoke College Alumni YouTube channel for future viewing. Please share your comments and ask questions as we continue our conversation, and our presenters will answer those as we continue our discussion. Tonight's event is titled NOKELive, Unexpected Connections, How Math and Physics Play a Role in the Olympics. It is featuring Olympian Richard Dick Emberger, class of 1960, and Roanoke College faculty member Dr. Roland Minton. Mr. Emberger began his track and field cross-country career at Bloomfield High School in New Jersey. While there, he helped his team win county championship in cross country, and he earned a record with a high jump of 6 feet and 1 inch. After arriving at Roanoke College in 1956, he was able to pursue his academic and athletic goals in part due to a scholarship. He credits Coach Charles Homer Bast with helping him become part of the track team on campus and suggesting that Olympic competition and the Decathlon might be in his future. After graduation, he received his commission in the United States Marine Corps, where he was able to compete for Camp Pendleton. And his Olympic dream came true on September 14, 1964, when he won the Olympic trials in Los Angeles. He placed 10th in the Olympic decathlon during the Tokyo Olympics of 1964. Dr. Roland Minton is beginning his 36th year on faculty with the math department at Roanoke College. He obtained his PhD in mathematical sciences from Clemson University, go Tigers, and he is a lifelong sports fan. He has taught different versions of a sports science course throughout his time at Roanoke, and it is currently a May term course at the college. Dr. Minton coordinates the STAT crew, which is a student group that collects data and creates reports for Roanoke College coaches. He has authored books on calculus, golf science, and sports science. He received a Virginia Outstanding Faculty Award in 2005 and has received Roanoke College Awards for teaching, professional development, and innovation. When you think of the Olympic Games, you might not think about math or physics, but it turns out they are much more connected than you might think. To help us explore that, I'm now happy to turn the event over to Dr. Minton and Mr. Emberger. Thank you both for joining us this evening.
All right, thank you, Lauren. Thanks for the nice introduction, for putting this together, and delighted to share some time with Dick. It's been a pleasure getting to know him. Thank you all for coming to this. So go ahead and start the slideshow. So I wanted to talk a little bit about kind of the academic side of things. But starting off with, if you want to know more about Dick's career, there's a wonderful article in the Roanoke College magazine from 2012. So next slide. Roanoke College has a very good sport management major, and we have a new data science major and a sports analytics concentration. Other than the movie Moneyball, a lot of people don't really know what data analysis is about. So I wanted to give a kind of a quick example of how you start doing this type of research and what it can do. Won't be very in-depth, but the question could be, do host nations do well in the Olympics? So got 2 screen captures from the medal tables from the last 2 Olympics. On the left is the Olympics just finished up in Tokyo. And there's an arrow showing Japan's medal count of 27 golds, 14 silvers, 17 bronze for 58 total medals. Going back to 2016, the previous Olympics, you'll notice that Japan was down at 6th place with 12 gold, 8 silver, 21 bronze for 41 total medals. So really by any measure, gold medals or total medals, Japan did a lot better as host than they had the previous Olympics. That's just one example. So you might want to do a more in-depth study. And there's lots of questions, lots of ways you can do this. You can do gold medals, you can do total medals, you could do percent of medals, because the number of medals has increased a lot over the years. So that's actually a factor that might matter. If you're talking about increase in number of medals, do you want the numerical increase or the percentage increase? Lots of different questions you can ask. But let's look at the next slide. And this was from the website 538 that does lots of great analytics. On the left is something pretty similar to what I just did. So you have host year for a lot of the hosts of Olympics going back to 1952. What's showing is the total medals won in the host year, and to the left of that is the number of total medals won in the previous Olympics. The column that's got the arrow pointing to it is the difference in the two. So Great Britain won 18 more in 2012 than they had the previous Olympics. Green is more, and you'll see only two places where it goes red, where there are very slight decreases in the United States in 96 and Finland in 1952. So that says host countries do extremely well at the Olympics, win a lot more medals. Once you have an answer like that, then what you really want to do is start to try to answer why. 538 had an answer, and that's the chart on the right, which shows the number of participants from the host country. So again, there's a column for the number in the host year, the number in the previous Olympics to its left, and the green column shows how many extra athletes they had in those years. And you'll see a lot of extra athletes across the board in all of these. A couple of reasons. It's easier to qualify for the Olympics if you're a host. Teams, for example, automatically qualify. And also, if you're decent enough, the travel for yourself and maybe coaches is much less expensive, so you can actually participate if you're good enough. So that's part of the reason why there's so many extra. What 538 did was say, maybe we shouldn't count number of medals, maybe it should be number of medals per athlete. And if you do that, the home advantage pretty much disappears. Now, I would kind of object to that. Using Great Britain as an example, if they had decided to field a men's and women's basketball team, they would have been in the tournament, but that would have added about 25 more athletes to their total, none of which would have had a chance to win a medal. And even if they had, team sports only count as one medal. So a lot of this increase is just athletes getting the privilege of just competing in the Olympics, really without a whole lot of chance of winning medals. So maybe that's not the right way to do things. I did something slightly different. So next slide. So what I looked at was, based on Great Britain's example, I looked at the number of medals won by the host, but also in the Olympics the 4 years before and 8 years before, along with 4 years after, 8 years after. And the reason I did this was a story I read about Great Britain that it's a woman named Helen Glover, graduated from university, answered a fairly vague ad that said, you can go to this site and try to qualify for Olympics training. So she went and qualified. She had been a field hockey player all through university. They told her they thought she could be a good rower. As of 2008, she'd never been in a boat, so that seemed like a bit of a stretch. But with the state support and the training, in the 2012 Olympics, she got a gold medal in the women's pairs. So part of the preparation to host is not just with the facilities, it's also with the athletes. You want to have a good showing, so you devote more time, more money, more effort into developing those athletes. And if that's true, then you ought to see a residual effect in the Olympics afterwards, which is what I'm seeing there, is that they have a big boost in the host year, but that also pays benefits for 4 years after and 8 years after. The whole program's been elevated. So there's a whole lot more you could do with this. I hope that gives kind of a small idea of what data analysis can be. Fairly simple questions, and it doesn't have to be hugely sophisticated analysis. Okay, next slide. I'm going to do a little bit with mathematics. What does math have to do with the Olympics? And I'll go with Dick's event of the decathlon. The decathlon's 10 events. If you can read the little labels underneath those two, those are the events in the order of competition: 100-meter dash, long jump, shot put, high jump, 400 meters, 110-meter hurdles, discus, pole vault, javelin, 1,500 meters. And you earn points in each of those, and the person with the most points wins. What is showing on top is a graphic from an article by John Barrow, and he collected data up through 2005, as the caption shows. And he was looking at average scores in each of the events. And what you see is a very unequal scoring pattern. So the 100 meters, the long jump, and the 110 hurdles, the athletes are scoring a lot more points in those events than in the throwing events: shot put, discus, javelin. And maybe not so coincidentally, the gold medal winner in this past decathlon, Damian Warner of Canada, had the best scores in the 100 meters, the long jump, and the 110 hurdles. So he was pretty much perfectly attuned to the scoring system. In case you're thinking maybe because that data was 2005, it might be out of date, down below are the scores from this year's Olympics, and the pattern's pretty identical. So it really seems to be embedded in the scoring system. So a mathematician's going to ask the question up at the top: what is a fair scoring method? And maybe you don't want something that's a little bit more balanced than that. All right, so next slide. The scoring system is another one from 538. Not only are the average scores very different, but if you can tell that the curves up at the top are going up at a higher rate than the curve down at the bottom, that shows if you got better at the event, how many extra points could you earn? And it's very few points in the throwing events, which already starts at a low level. And you can boost yourself a lot in the running events: 100 meters, 400, and 1,500. So again, it seems a little bit unbalanced, a little bit unfair. So next slide. Fortunately, I guess coincidentally, there's an article in a very recent journal, Mathematics and Sports, that addresses this issue of fairness in decathlon scoring. So I'm going to make you look at one formula. Not too bad, maybe. It's kind of in the white there. In each event in the decathlon, your score in that event is a constant A times your performance, which is P, minus kind of a minimal baseline B raised to a power C. And each event has a different A, B, and C, and that's where the difference in scoring comes from. So they're suggesting here that you replace P minus B. So that's comparing your performance to a very minimal bad performance. Instead of that, maybe just divide by a record performance, a fantastic performance, but otherwise use the same formula. And then, as a mathematician would do, identify certain axioms, rules that you want to have happen. So the event identity doesn't matter. That means if you score 1,000 points in the pole vault, that should be as good as getting 1,000 points in the 100 meters. It shouldn't matter which event you get your points in, just how many points you get. You should have to compete in all the events. It is supposed to identify the best all-around athlete. And you've got all these constants, A, B, and C in the current system. The final ranking shouldn't depend on those values. So in other words, if you had somebody who was going to win, it shouldn't be possible to change those constants, change the formula, and have that person not win just because of a change in formula. And Dick actually has a story, I think, of that happening in an actual event. It turns out you can do this. Regardless of what those constants are, you can get the same winner, same second place person, and so on, if instead of adding the scores, all you do is multiply them. So a very interesting and simple idea gives you a lot of extra fairness in terms of those rules. And that's kind of a very mathematical way of looking at things. Right, next slide. Not going to do much with this with physics, but physics, you can answer some kind of basic questions like maybe a maximum pole vault. We can talk about that later if folks are interested. The pictures are showing changes in high jump. Picture on the left is from the Olympics, 1956, I think. And you've got the athlete going over face down. And picture's a little unfair, but basically the entire body is up above the bar as he's crossing it. Picture down below is from a more recent event. It's called the flop, which first showed up in the Olympics in 1968. And I think Dick again was adjacent at least to some of those changes in technique. And these athletes go over backwards and have a severe bend, as you can tell with that person. So what's going on there is the only part of his body that's even with the bar, his hips, that's certainly above the bar, he's clearing it, but most of his body's down below it. So he doesn't have to go all the way over the bar. In physics terms, his center of mass can go through the bar and actually under the bar while the relevant body parts are clearing it. So you don't actually have to jump as high to clear it going backwards as you did with that old roll technique. So in this case, physics is explaining why a new technique is a lot better. I can't go into a whole lot of detail, but modern physics is probably less involved with these type of simple explanations, which I think are great fun as a fan. Physics role probably now is more in a very technical, precise design of equipment. So the pole and the pole vault has undergone lots of changes. The actual track that they run on is better. The shoes that they run in are better. Pretty much all of the equipment has been redesigned with aerodynamics and wind tunnels and computer models using the physics. So we can get back to this as much as folks are interested, but let me stop there and turn it over to Dick for a while.
Good evening. It's great to be here with you, Dr. Minton, and I do definitely have a few stories since my tenure at Roanoke, 1956 to 1960. We've seen tremendous changes, especially in the pole vault, the high jump, which you mentioned with the Fosbury flop. My career was just coming to an end when Dick Fosbury brought out the flop, so I had no opportunity to try that. But in the old days, Roanoke, we had about 700 students. And when I met Coach Bast, he convinced me, obviously, that he would love to have me on the cross-country team and the track team, which, of course, enhanced my career later on in the decathlon, since I was always running for my life in the 1,500 meters to qualify for teams to go to Europe as well as the Olympics. And I'll go into that in a little bit more detail later. But at Roanoke, we had a basic pit with hay bales and sawdust. And I think it was just a small macadam runway. And the same thing in the pole vault. I remember we had two poles. We had an old Swedish steel pole, which was thin at the top and thin at the bottom and had no bend at all. And there was a gill pole that really had, at my level, 12 feet, 12.6, had no bend at all. But Don Bragg used to use it when he competed in the big events in Madison Square Garden, and he was like 6'4", 2 something, and he could get a little bit of bend out of it. And at the same time, we had the bamboo poles that Dutch Wormerdam used to set his records. So that's a little background in that high jumping and pole vaulting. Basically, because we were a small school, Coach Best really encouraged us to get involved in a lot of different events. And so being a multi-event athlete, I high jumped, pole vaulted, long jumped, and I would run the high and low hurdles. And every once in a while, I might throw in the shot. And I think I threw the javelin once. But there was no such thing as the decathlon back at Roanoke at those days. So about my junior year, Coach Bass said, you've done really well in all of your events. I've set a few records, had a couple state records at the time. And he said, you probably would make a good decathlete. So that always stuck in my mind. And when I graduated in 1960 with a commission in the Marine Corps, and a little story there, we was down on the track one day and all of a sudden this gentleman shows up in his spiffy uniform with a red stripe down the side. He said, Coach Bass sent me over and said, you'd probably make a good Marine. And so I took their test and passed it and went on to basic school. After graduation, received my commission in the Marine Corps. I spent 8 months at Quantico and competed with their track team there. And we saw some substantial changes in the pole vaulting at that time. Aubrey Dooley was in the program. He was a pole vaulter at Oklahoma State, and he brought the first fiberglass poles to the East Coast. And we had a gentleman, John Ulysses, who was on the team, picked up on this, and he ended up setting a world record indoors at 16-1 with the fiberglass poles. And later on at Camp Pendleton, Dave Tork used the same poles, and he jumped 16-2 and set a world record there while I was at Camp Pendleton. So my Olympic career basically started at Camp Pendleton. I got into my first first decathlon at the Mount San Antonio Relays. I was in the hot dog heat, which was off kind of in the back 40 with all the jumping events, because we had Bill Toomey there and C.K. Yang, who was supposedly going to win the Olympics that year. And he broke the chart record by jumping like 15.5 or something like that. And I think it went up to about 1,000. So his performances may have started some of the changes that we saw, because they did change the decathlon tables in 1964. So that decathlon, I scored 7,292 points, which enabled me to go to the AAU championships in Corvallis, Oregon. And there, again, I had to run for my life. I was in, I think, fourth or fifth place. And I needed to run a very good time. And I ran, I think, a 4:26 and beat Dave Edstrom, who had been on the team in 1960, and got a trip to the Soviet Union with that against the Russian team in Moscow that year. In my Olympic year, I qualified for the Olympic trials at Mount San Antonio College in the AAU championships with a 7,502 point performance, which put me in sixth place. So the two winners were supposedly on the team, which were Paul Herman and Russ Hodge, and no, Don Geisy, I'm sorry, and Hodge was a fourth. And so we all were then competed in the Los Angeles Coliseum. And fortunately for me, I had 4 personal bests in the high jump, the pole vault, the javelin, and the 1500, which actually put me on the team. And as Dr. Minton mentioned, my story there is quite interesting, since Russ and I tied at 77-28. And the way the rules read, that if you tie, then you go to the person that won the most individual events. And luckily I had won 6 and he only had won 4 between the two of us. So I made the team. But the interesting part was Russ ran a 4:12.7 and I ran the fastest time of my life, probably running like a scared rabbit, 4:11.9. And my score was right in the middle between a 2-point spread on the decathlon tables. And I think Russ was the same. So if he had scored and had run a little bit faster, or I had run a little bit slower, he would have been on the team and I would have been history. So that's my little story there. So my Olympic opportunity hinged on, just like in a swimming event, maybe 1,000th of a second on the pool, or 1/10 of a point on the decathlon tables. In Tokyo, it was interesting. We trained at Cal Poly Pomona for about 3 weeks, got all of our gear, jumped on a plane through Anchorage to Tokyo. And since the decathlon was towards the end of the event schedule, most of my time there was spent training. I did get to travel around town a little bit. A couple of remembrances. I got to see that they had a triple-decker golf driving range there that I remember. And they took us bowling one time, and to my amazement, this is back in 1964, they had what we have today, where you hit into a net, and they had Pebble Beach and all of these interesting golf courses at the time. So I thought that was kind of unique. Probably also one of the big changes was at Pendleton. Of course, we jumped with hay bales and sawdust. I think in the meet in the Soviet Union, they had chips of wood chips in a net bag. And when we got to Pendleton, because torque was jumping so high, they had a group of guys came in from Los Angeles called Porta Pit, and they took a whole bunch of foam rubber pieces and stuffed it into a net bag, and that became the pole vault pit, which we call Porta Pit today. So that allowed pole vaulters now also to land on their back and not on their feet, as of course our high jumpers with Dick Fosbury back in '68. As I remember back, the weather was kind of cloudy and misty, and the track wasn't wet, but it was not up to probably the levels we see today with the synthetic tracks. We were the last of the brick clay type era tracks, and it did create some problems in long jumping. And I had a tough time with the pole vaults because I had a blanket around me. It was a little coolish, and I touched the fleece blanket and I was losing my grip on the pole, so I didn't do as well in the pole vault. But I did well enough to get 10th and scored 7,000, I think 292. But the new tables came out that year, and that reverted back to, I think, 7,113 points. So I was very privileged to have been able to compete for Roanoke College, Camp Pendleton Marines, and for the USA in the Tokyo Olympics. And I know we're going to have a question session, so I think I'll just leave it there.
Well, first, actually, we did get a comment from Paul Dellinger. He says, it's great to see Dick again and catch up on all of his accomplishments, and also to learn how Homer Bass was involved in your track career here at Roanoke College. So one of the questions that I feel like I had for you, Mr. Imberger, was, of course, the Olympics this year were held in Tokyo again. So first, did you watch? And if so, how was it different compared to when you were there?
Well, I did watch, and initially it seemed like there was a little too many participations going on. When I competed in '64, we had 180 events and about 5,000 athletes at the games. This year in Tokyo, there were like 339 events and probably triple the amount of athletes. I did enjoy, for the younger generation, the bicycles and the tricks that they did were amazing. And the 13-year-old on her skateboard did so amazingly well. So I thought for the younger generation that worked out pretty well. But I was more interested in the traditional events, and it seemed like there were so many different channels and going on that it was hard to try and see everything at one time. But I did get most of my information on my cell phone for the decathlon, which I was interested in to see if my 4:12.9 held up this year with these tremendous athletes that competed in the decathlon. Their performances were outstanding, and I was able to say their fastest time was 4:26.3, and my 4:19 held up at least in this Olympics. So I was proud of that.
Yeah. One of my coworkers, who's also a runner, pointed that out to us as well. And, I just found it fascinating that, the time that you ran for the 1,500 event would have been a first place time in this year's Olympics. I just think that's incredible. And there's maybe a somewhat unknown fact about yourself that I think you might want to share with our viewers. If you don't mind, would you please tell them how tall you are? Because I think that really is interesting with how high you were able to jump in the high jump.
Well, back in the old days, I was just under 6 feet. Now I'm a little bit shorter, but I was able to actually at the All Marine Championships, I had the best jump ever of 6'7". So I was proud of that. And I think my highest jump in the Olympic competition. Well, at Roanoke, I jumped 6'5" and a quarter and set the indoor record at the BMI, their indoor field called the Pit, which was always fun to go to each year there. And so I was very fortunate with my jumping, especially.
And Dr. Minton, I was curious, you talked a lot earlier about the home field advantage, and it's obvious that that certainly plays a role with the Olympics. This year's Olympics were slightly different because of COVID. They hosted several events at different times compared to where they had hosted them in the past. So several of the swimming events, for example, were held early in the morning instead of late at night. And I was wondering if you had, any thoughts or if there are any statistics about how changing the competition time might impact an athlete's performance.
Great question. And I certainly would like to hear Dick's opinion on that as an athlete. I would think that travel is disruptive in a lot of ways. You get your body tuned to being up at certain times. And if you're on a different time schedule, I would think it would affect things. So there's been a lot of research into home field advantage in a lot of different sports. And certainly it's there in all sports, and a lot of it's due to referee bias. There's been studies of referee bias in the Olympics. It has a little less to do with just the kind of human thing of wanting to side with the home team, and more with maybe the politics of the Olympics. There have been some scandals in some of the, like gymnastics and figure skating, where it's very subjective, and there's been some collusions with judges. A huge benefit of the decathlon is you can't do that. It's just all about your performance. I would think that the time would be hugely different. And also with the decathlon, the 1500 meters shows up as being the lowest scoring event. It's also the last one. How tired are you at the end of this, is mentally and physically? I would think that would be a tough one to get through.
Yeah, well, fortunately, I with my training from my college days, and we were fortunate at Camp Pendleton. We had Tommy Thompson from the Naval Academy. His son lived in the area, so when he retired there, he came out and he helped us. He won the 110 meter hurdles in the 1920 games in Antwerp. So he was a great coach, and he really helped us with our conditioning, and we did a lot of runners. And of course, we had Billy Mills there at the time, so he won our 10,000 meters for us in the games that year. And I think it probably would affect, because with 10 events, you have to spend an awful lot of time stretching, get ready for the next event. And this is where Roanoke helped me, because I'd run from the long jump over to the pole vault and then over to the high jump, and then maybe go run the hurdles. So I was kind of used to that, this hectic type schedule, but I would think that it would have some effect on the athletes if you went early in the morning, and then maybe the next day you had to do some of the events later in the evening. So
one of the other things that I noticed about this year's Olympics was the weather, and how the weather impacted several events. There were a lot of reports about the waves, and how the waves were impacting the surfers, and how the heat was impacting the runners and the track athletes. And so, I guess my question for you, Mr. Emberger, is what was the weather like when you were there? And, is there kind of any specific data on how weather impacts athletes? And that half the question is for Dr. Minton. So.
Well, in terms of what the weather was like in '64, it was drizzly and cloudy. So the runways were, they had done a lot of studies and had studied it for 3 years to make sure that the runways wouldn't, if they had a distinct rain. But it did affect your running, because it got chewed up a little bit, and it would throw your steps off a little bit. And so I felt definitely my performances were way under what I did at the Olympic trials. So it definitely does have an effect, weather, of course, especially if it would be raining or this extreme heat. Of course, you'd need a lot of fluids and things of that nature.
So there have been some studies about, this isn't directly about weather, but kind of some athletes process oxygen better than others. So for a long distance running event, high altitude is a severe problem. And I think a lot of long distance runners train at high altitude to try to get used to that and build up the oxygen processing.
Right.
Obviously, I'm getting near the edge of my knowledge about this. I would think high humidity would work the same way, that I always find it very hard to breathe. I'm only trying to play golf in high humidity, but I would think it'd be similar, that it could affect how you process oxygen and are able to compete.
Yeah, that's very true. Since I was able to compete in '68 in the Olympic trials, we went up to Echo Summit, which was 72,000. I think Mexico City was like 76 or something like that. And before we left, they had the experts were saying, you really got to take it easy the first couple days and get acclimated, because there's a lot less oxygen up there. And I remember some of the sprinters got up there and they, had a pretty good workout, and they found themselves laying down, fighting for air. And a couple of them ended up in the hospital for a short period of time because they didn't take the precautions of, the big change in altitude. And of course, weather would probably have the same effect. I know distance runners would love to have a, cool, cloudy day to run their marathons in. So, but I'm sure the heat did take effect. But these athletes in the decathlon this year were tremendously trained, and of course they had all the modern technology and this testing equipment that they have to show every little piece of your jumps and where you're going wrong and where you're going right and how to make it better. So we've come a long way since 1964.
Dick, there's a question for you, and I'll go ahead and read it. It's from Jan
Sure.
Minton, who's a very good friend of mine. So that's my wife. She says, did you participate in the opening and closing ceremonies? Did you live in the Olympic Village?
I did. And I did live in the Olympic Village. It was like a big apartment complex. And if I remember correctly, I was thinking back on this, I think they had 2 athletes to a room, and then there was a hallway and doors on either side, almost like a college campus type thing. And I think Dave Wheel was he was a discus thrower from Stanford, was my roommate while I was there. But yeah, it was like a college style. The food was great. And if you went over to the French table or Italian table, you could get a nip of little wine occasionally. So it was kind of interesting. And I had one story where this gentleman was garbed in a very colorful outfit, and I wondered whether he spoke English or not. And so I tried to tell him I'd like to take his picture, and he says, "Sir, it would be a great pleasure for you to take my picture." Spoke the King's English, so I thought that was kind of interesting. But it was the village was tremendous. They had everything you could want back then, and I'm sure it was even better this year in Tokyo.
So Dr. Minton, one of the other things that I wanted to ask you about, you touched on it a little bit with, how you were saying there are certain discriminations, maybe sometimes for some of the events with gymnastics and ice skating, things like that, where there are judges. Of course, one of the biggest headlines from this year's Olympics was Simone Biles and the unfortunate situation where she was not able to compete due to the fact that she couldn't figure out how to twist in the air. She got lost. And so I was wondering if there's anything that you can provide that kind of talks about the physics of that and why it was maybe such an issue for her.
I don't know a whole lot about this. My understanding with the figure skaters that do the very rapid spins is that they need to be able to focus on a particular thing, or they get lost in the spin, dizzy. And I think we've all experienced that a little bit. We're not sure, the room is kind of spinning. We're not sure where we are. And if you're doing 3 somersaults with 2 twists, I would think that's going to be a real issue. And I don't know the technique they use I don't know if they pick out specific points or have some sort of natural kind of internal gyroscope to keep straight. I have gathered, we've certainly all gotten educated about the twisties. And so I gather it's relatively common that it's kind of shows up as a matter of confidence. And her last attempt before she dropped out was a vault where she went to a much easier version of the vault with fewer twists, I think, and still wasn't able to land solidly. And just, I guess, wasn't. So what they have to do to land nicely, you kind of make your body small to get the twists and the somersaults done efficiently. And then you spread it back out to stop the twisting and the somersaulting. And you have to know when to pop out of it. That's a big thing in diving. When do you get out of your tuck position and come back out? Same issue for gymnastics. And if you're a little bit off, it wouldn't have to be much at all. You end up in a very dangerous situation. So I'm guessing it's part of that is just not entirely knowing when to do what with your body to come out of the gymnastic and land properly.
Mr. Amberger, when you were competing in the track and field events, you've kind of went through the evolution of track, and especially with the high jump, and how the pole changed over the years. Do you have a preference for which pole you used? And if so, what is your preference and why?
Well, as I mentioned earlier, we started out with something that didn't bend at all. And just having to pick up a pole and did it, I learned it all incorrectly. And Coach Bast even said once or twice that he was kind of a step ahead of us, trying to, in some of the events that he wasn't, completely knowledgeable about. And so I ended up going up the wrong side of the pole as a collegian. And when I got to the fiberglass pole, where you want to spread your hands out so that you can bend the pole and get the return. But the problem there is, I'm sure that Dr. Minton could talk to that, is the physical strength of the pole. They have different size poles for how high you hold and how much bend you want to get out of it. And so a young man might take a real light pole and he can bend it tremendously, but he'll get up to the top and it'll just mush out and you'll fall back down again. So the stiffer the pole and the ability to bend it because of your forwardmost speed down the runway, when you put it in the box, you apply this torquing force to get that pole to bend so that you can get up underneath it. Makes a big difference. And I'm sure Dr. Minton could speak to that in terms of physics involved with the pole. So I'll just leave it there. I did well, but I always ended up putting my hands together at the same time. I was never able to get that thing spread out and look like these guys do today, jumping 20 feet, 19.9, something like that. My best was 13.9, and I was lucky to get that.
So
It sounds like, and I don't really know this very well, it sounds like poles would be engineered to fit the unique characteristics of the vaulter these days. I know more about golf, and golf clubs can be very individualized, and
Right.
you want, it's not that all bend is better, it's some types of bends are better for the particular swing that the golfer's doing or the particular pressure that the vaulter is putting on it. So I would guess poles are fairly individualized now. I don't know if you know if that's true.
Yeah, basically, when I came to Pendleton and Dave set the record, they were making poles in Costa Mesa, California, which was about 30 miles down the road. And so he used to go to the plant and they would, I think it's fiberglass wraps, basically. So it just depends on how many wraps you put on the pole to see how stiff it's going to be. And then as you get up higher, you almost have to hold higher. And so the higher you hold and the stiffer the pole, the more bend you can get out of it, which is going to catapult you up over the bar. If you don't have the stiffer poles, then as I said, you'll get to the top and it kind of mushes out and you'd come back down, not getting over the bar. So yes, they're individually set up by gradient degrees as to how stiff the pole is compared to how high you hold and how much you're able to bend it, like a gymnast up at the top of the pole.
Dr. Minton, we have a question for you from our audience. Penny Whitmore has asked, have statistics ever exposed cheating in the Olympics?
Let's see. I think there's probably two answers to that. One is the thing I'm thinking of was ice skating, and I think it was the ice dancing. And there was a big scandal a few Olympics back where several of the judges colluded to give the gold to a Russian team rather than a Canadian team, I think, that had probably earned it. And that was less about statistics exposing something that wasn't known as it was corroborating what was evident to the experts, that the Canadians had skated better than the Russians. And eventually enough pressure was put on some of the judges to admit that I think they'd been paid off maybe. Otherwise, there have been a couple of articles that indicate that in those judging events, the judges tend to go together as blocks. And you can call that cheating or not. So say Eastern judges, Russia and some of the other countries there, those judges tend to vote the same way, and maybe a US judge and Canadian judge vote the same way. If that's either, you might think it's favoritism, it might more accurately be described as taste. In terms of some of these athletic events, what is beautiful and well choreographed. And if you're from one culture, maybe a more classical bent is better than a more rock and roll bent. And the US judge probably sees it more rock and roll. So it's a partial yes to that. But there certainly are differences in judges. And most of the events now have gone to systems where maybe you throw out the top two and the bottom two to try to prevent it from affecting the outcome too much.
So I guess this might be for both of you. Of course, athletics has evolved over the years with athletes becoming stronger and faster with various training techniques that are maybe available now that have not been available in the past. So I guess, do you feel that that is fair, I guess? And then what kind of impact do you think it might have on future Olympics? As far as, who knows what the next technology is going to bring or what the next generation will bring with their strength or with their speed. Can either of you talk about that at all?
Go ahead, Doug.
Yeah, well, I can remember back in 63, 64, the big thing was strength building with Diana, if I remember correctly. And we saw some pole vaulters, some shot putters that gained a lot of muscle mass because they had used that, I guess, for veterans coming back from the war to build up their muscle mass, and helped their ability to throw further. I know that was in the 60s, but of course we have these doping committees today that are and the technology to kind of find that, as we've seen with a couple of our sprinters that had taken some type of whether it was an antihistamine for a cold or something like that and weren't able to compete. But there was some of that back in the 60s where some of the athletes were becoming, I think some of the Russians were eliminated because of it for their program that they had from when they were small kids, if I remember correctly. So yeah, it's been around. And of course, blood doping, we've seen that with the cycling and stuff like that. So everybody's looking for an advantage, but you know, it goes against the concept of sport and why we're there, I would think. You know, to use your physical talents, not using it from other means.
Yeah, and there's maybe a new place we can get into now with genetic testing and genetic modification. That's yet another place. There's somewhat controversial, but there's plenty of evidence that some of the events you can have genetic advantages. To take a non-controversial version of it, if your genetics makes you 7 feet tall, you've got an advantage in basketball. That's not a, I mean,
Sure.
I don't know if you want to call that unfair or not. It brings a lot of things into question, and certainly it's kind of an arms race with the use of various performance enhancing drugs. And there's increasing controversy over gender. What does it mean to be a female athlete these days? It's not maybe as clear cut as we would like it to be. So there's some difficult questions there. Absolutely.
Yeah, you know, and this is maybe more of a hypothetical question, but Mr. Emberger, you know, it was obviously much more traditional when you competed with men's events and women's events. So I guess, you know, do you maybe see a future for the Olympics where it's just the track events or the gymnastic events and the male-female designation is sort of taken away? You know, do you think that might be a possibility in the future?
Interesting question. Yeah, I definitely think that the Olympics overall have become too spread out. And I know a couple of years ago they had thought about, you know, holding separate events, holding a group of events one facility, and then holding other groups of events somewhere else to make it more crowd friendly, where you don't have to see too many events. In terms of men and women, yeah, that's an interesting question. I know I had one of my relatives asked me about this young lady, I forget her name, who wrote an article about why can't women have a men's decathlon? Of course, using their own equipment. Of course, their shot is a little bit lighter and their discus is a little bit lighter, but all the other events, it is an interesting concept because they do the heptathlon. They only do 8 events. And I could see that in the future. I don't see where there would be a problem with that if they use their own. But together, I would generally think that in a lot of the strength events, of course, I think the male athlete has a distinct advantage. In some of the other events, the female athlete has an advantage. So that, I don't know, that would be interesting to see how one might figure that out in the future. But I can see a decathlon in future Olympics or in future competitions for women as well as for men using their equipment.
I can only imagine, Dr. Minton, how your brain must be spinning a little bit right now too, thinking about how the statistics might change if something like that were to happen too.
Sure. It would keep some of the data analysts employed, though. That would be good. Give them a new problem to work on.
Well, we are getting close to the end of our time. So I definitely want to say thank you to both of you, Dr. Minton and Mr. Emberger, for joining us this evening, and to all of you who joined us online for our NOKELive event. We invite you to join us for our next event, which will be held on Thursday, August the 26th at 7 p.m. Eastern Time, called NOKELive, Hearing with Their Hearts, How Deaf Dogs Rock. And that will feature Dr. Chris Lee and his wife, Christina, and the program that they have helping deaf dogs find forever homes. For more information, you can visit roanoke.edu/alumni and visit the Alumni Hub. Also, please check out the Roanoke College main webpage for other online and in-person events. Thank you so